good afternoon to you, everybody. Thank you very much for joining us here at 9.connects. You are in the right place if you are here for our webinar in regards to, well, depending on how you want to call it, mechatronics design, co-design, ECAD-MCAD collaboration. So we're going to start off here on the bat with a couple of objectives, what we're going to try to do here today. First and foremost, want to talk a little bit more about the idea of step files. That's been the ability for people to push stuff to and from between MCAD and ECAD for the really the last decade or so, and there's been some better tools that have been put out, and that's what we're going to demonstrate here today. We want to show you the path between Altium Designer and SOLIDWORKS CAD, because a lot of people know that this path exists, but what is the path that it takes so that you can push stuff pretty flawlessly to and from Altium Designer and SOLIDWORKS CAD? So we're going to show that to you as well. And by the way, just as a side note, I know that Altium is going to be putting out their 365, and they're doing this whole co-design thing, and I guess it's going to go above and beyond something in terms of SOLIDWORKS and in terms of other tools. So if you understand how this flow works, more than likely that's going to be the same flow that they're going to use for other tools as well. So if you're not necessarily using SOLIDWORKS CAD, take a look at how this flow is going to work, because it probably will be the same. Just want to do an ultra quick understanding of the ECAD flows. One slide, about 2 minutes of discussion on that. And the reason I'm putting in there is because we do have some mechanical folks joining us here today, and I think they need to understand where we're coming from with our flow, which, as most of us electrical folks know, is a little bit more convoluted than the mechanical flow. And then, of course, we will actually demonstrate this between Altium Designer and SOLIDWORKS CAD, and we'll certainly have time for questions and answers. I don't believe the demonstration here and the discussion will go beyond 30 minutes today, so you guys will get a little bit of time to get back to other things before hopefully a good break. Before we go on here, I do have a polling question for you, so we'll put that up on the screen. Okay, so we're going to close the poll over here. So a little over 2/3 of you are using the classic method of pushing either a step or an IDF or an IDX or Parasolid to and from your tools here. So that seems to be the prevalent way of doing it. And that's a good thing, because that means that in the last 10 years, there's been a lot more co-design going on over here. And then there's a good 15, well, actually it's 14, so I'm rounding here, but it's 14% of you just said, no, we're not doing it. And there's also a good portion of you using desktop EDA as well, which is also a really, really great tool. So what's interesting here is that very few of you are using any of the other ones that have been developed either by Altium or another EDA tool. So hopefully you'll find this of some value to you. So we're going to move over here and just take a look at a few more slides, and then we'll get on to our demonstration. So what's interesting about this, and when I was trying to come up with a name for this webinar, what we found is there's actually a number of different names that people are using. So you may have heard it as ECAD-MCAD collaboration or MCAD-ECAD collaboration, depending on which side you're kind of coming from. You may have also heard it from us. We were calling it Mechatronics design because we were trying to promote SOLIDWORKS PCB and this connector some time ago, and we associated ourselves with SOLIDWORKS. And now, at least recently, and this is the term that I think Altium has come up with, and I have to admit I do like it, it's called co-design. So the point I want to make over here is that all three of these names pretty much mean the same thing. You're trying to push stuff from the electrical side over the mechanical side and vice versa. Okay. Oops, a little touchy over here. So what I want to show you is kind of the current thing that most of you are probably going through right now. And this is what happens when you take care of a step, or you're trying to create a step and trying to hand it over to the other person. You have to basically create this. So whether this starts in the ECAD side or the MCAD side, it doesn't matter. This flow will actually work the same way. And then afterwards, you're going to export this. Then you're going to write an email to your colleague saying, hey, it's ready. Most of the time, these are so large that you're going to, hopefully you can attach it, but if not, you may have to put an FTP file site, or you got to put in a shared server site. And then you're going to send that email. That other person is going to receive that email. They're going to try to download this wherever it's been placed, and then they're going to import this. And the biggest problem that you see more often than not with the step files is that they're very difficult to kind of work with. They're great to see visually, but they kind of are stupid creatures in a sense that, hey, there's the graphical representation, but there's no intelligent data behind them. And I think that's what makes it really difficult to work with things like step files and even Parasolids to some degree as well. So what are the examples, the disadvantages that we just saw? There's a lot of importing and exporting hassles, so a lot of administrative work behind the scenes. In SOLIDWORKS CAD, it certainly does come in as a bunch of assemblies. And that's the biggest problem, is that if you're working on the mechanical side in SOLIDWORKS CAD, you have to do a lot of cleanup to make these things actually look like what they represent on the electrical side. So there's a lot of cleanup work that has to be done. And on the SOLIDWORKS PCB side, it just comes in as one blob. So if you've got a board with a bunch of parts on it, and you have this in SOLIDWORKS CAD, you import it into Altium, and you look at it, and you think, well, great, there it is, but you can't do anything with it. You can't break it apart. You can't salvage things off of it. And as I mentioned earlier on, it really has no intelligence. It's really strictly for aesthetic purposes only. So it does help, and it's a huge step forward compared to the chasm that used to exist between these tools, but it's still a bit of a hassle to work through step files. And Parasolids, they're a little bit better, but again, not much better. So what I want to do is kind of show you how this flow works between Altium Designer and SOLIDWORKS. You'll notice there's also SOLIDWORKS PCB here too. And the only reason I show this here is because Altium Designer did develop SOLIDWORKS PCB. We've talked about that in a prior webinar, but I also wanted to kind of show you what the interfaces look like here. So if you have Altium Designer, in order for this to work, you have to have something called the Pcb Connector. It's an extension in the extensions menu in Altium Designer. Now, yes, you'll see it over there, but don't download it unless you got a license, because it will try to install, and without a license, it won't do a whole lot for you. So it does require a license here. There is this thing called the Pcb Services. This is really, really important, because what this allows us to do is it allows us to work in our native format. So in Altium Designer, I don't have to try to somehow use a third-party format, and I don't have to use SOLIDWORKS' format, and vice versa. SOLIDWORKS doesn't have to use Altium's format or a third-party format. So the Pcb Services acts as a number of different things, but primarily for somewhat of a version control purposes, because it does know what the head revision is, but more importantly, it allows you to work in your native file sets. So if you're in Altium, you work in Altium. You're in SOLIDWORKS, you work in SOLIDWORKS. But these are the connections that you would use to get to this. The other thing here with the SOLIDWORKS PCB Services, okay, and I'll call it SOLIDWORKS PCB Services, that if you purchase the connector or you purchase SOLIDWORKS PCB, this services comes with it. So you don't have to buy an extra license. You don't have to buy the service separately. So with the connector extension, as a part of that, you also have to download the services, because they ain't going to talk if the services are not there. This services, if you're a one-man band where you're putting everything on your machine, both SOLIDWORKS and Altium, it'll work just fine. If you're going to have a number of people share these files between each other, then this can certainly be put onto a network server. So that is the flow that we're going to see over here. Okay. Now, the reason I put this slide over here is for those who are in the MCAD world to understand the craziness that we deal with here on the electrical side of things. The mechanical folks really have it easy. And when I'm talking about easy, they have it easier because of their flow, not easier because I think still what they do is really amazing, but their flow is a lot easier, because what they do is they start with parts. And from parts, they pull together these parts to create something called an assembly. It's very, very linear. And if you think about it too, not only do they create their, I'll call it schematic if you want to call it that, they also make their library parts at the same time. So when you're making a part, you can also turn it into a library part, and those parts eventually become an assembly. Very, very linear. That's why I think their flow is just beautiful. We folks on the ECAD side have it a little more difficult, because we actually do our designs twice if you think about it. The first way we do it is something through, it's called a schematic, and that is a conceptual drawing. It's dimensionless. That's why you see all these little squiggle lines or these parallel lines. There's a whole representation of all of these components out there. There's over 100 of these symbols out there, and that's exactly what we have to have as a symbol library. So the symbol library contains our symbols. Well, guess what? After we do our schematic capture, we have to push what's called a net list over to our PCB layout so we can actually do the physical layout. And we have yet another library to do that. And fortunately, in things like Altium Designer, we can embed the components in there so that when we do the layout, we can see it both in 2D and we can see it in 3D as well. So the reason I bring this to your attention is because of the fact that we have to keep these libraries in sync with each other. The way this whole flow works is it actually starts from the electrical side. And that's just something to keep in mind, is that if you're trying to do a co-design together, it really needs to start from the electrical side and then push to the mechanical side. And what you're going to see is that once you kind of have this flow going, it's easy enough to go. But from the start point of view, you really want to start it from the ECAD side. So just wanted to show that to you. Here's just a very, very quick graphical representation for it. And we'll, of course, obviously demonstrate this here in just a moment. So we have our schematic. We go into we push our information into the PCB. From there, we can, in Altium Designer in particular, we can take a look at it from the 2D view, and we can also view it in the 3D view. And then through this whole services, we can push it over to the SOLIDWORKS CAD side and vice versa. So that is our flow on this here. One other thing I have to mention, of course, we're dealing with 2 different companies over here and 4 different steps. So you have to be a little bit careful about the versioning. Fortunately, both Altium and SOLIDWORKS released their new stuff at around the November, December timeframe. So there's about a 2 to 3 month period of time where one has got something out a little bit sooner than the other, and so there's a little bit of a mishmash that has to go on over here. But during the rest of the year, pretty much you want to be in sync with it. This feature that I'm going to show you, most of this already existed here for the last 3 or 4 years. It's just that there's new things that they added in the 2019 version, which includes the copper and the silk. And so we will be showing that. But for this configuration, what you'll need is at least Altium Designer 2018. My understanding is 2019 will work fine. The Pcb connector has to be the 2019 version. So there's a 2018 version out there, but again, it's going to be limited. It won't have the copper or the silk. There's also the Pcb Services. The 2018 services will work just fine. As a matter of fact, they encourage you to use that one. The 2019 is going to be coming out here, and it'll have a few more robust features, but for our purposes, 2018 will work just fine. But you do have to have SOLIDWORKS CAD 2019. You cannot use 2018 if you want to see the copper and the silk. So that is the current configuration. Hopefully in a month or two when you look at this, this will hopefully be a non-issue for you, but these are the ones we're going to have to use for this to work. So from Altium, we go through its extension. There's the connector running in the background, which we call the services, and then it goes into SOLIDWORKS. So that's all we're going to show over here in terms of the PowerPoint presentation. What I want to do now is I actually want to get into the good stuff. So we're going to escape out of our PowerPoint presentation here, and we're going to bring up Altium Designer. All right, so what we're doing over here is going to show you a couple of things in Altium Designer that you need to do to get some stuff set up. We're going to start off in the top right-hand corner over here. And by the way, here to assist me is my colleague Travis Elmer. So Travis is very good at SOLIDWORKS CAD, which will help us here today. So that's why you see his name there in the top right corner, because he's logged in. But what he's going to do here is he's going to be driving. I'll be talking. He'll be driving it here, and so you'll see a few things as we're going along. On the top right corner, you'll see that he is logged in, and you also see that it says the Altium Vault. So why is it called the Altium Vault? Well, the Pcb services that I mentioned that is required. So when you purchase the extension, the services do come. You download the extensions from SolidWorks. Well, they never changed the name to Pcb Services. They still call it Altium Vault because effectively it is a derivative of the Altium Vault. So that's why you see that here. But he has logged in. This is local to his machine here. The second thing we wanted to mention to you is that extension. So where's the extension? On the top right corner, these things called the extensions and the updates. So Altium right now is pulling that up. You'll notice that we are in the installed area. So we have, okay, and we have installed this here. And if you click on the name, you want to make sure that you have version 2019. And again, don't try to install it unless you got the license, or you may have some issues with trying to reinstall it again with the license later on. And you want to make sure it's the 2019 one if you have the silk, if you want the copper and the silk. There's also a 2018 one as well, but again, click on the name to make sure that that is what it says it is. So we do already have that installed. What I want to also show you too is there's something we have to do with our projects that's a little bit different from the normal flow or cycle, and that is we need to basically manage this project. So I'm going to show you the two ways that we can do that. So on the top left-hand corner, we're going to go into File, New, Project, and then you'll notice that there's actually two projects now. This is something they recently added. If we pick the one that's on the very, very top, it'll just give us nothing more than what's called a .prjpcb file, and that's perfectly fine if that's all if you know what you're doing and you want to just get a project going, that works great. But if you're going to set up a managed project, you actually have to click on the one that says Project with the 3 dots after it. So it's going to bring up its dialog over here, and we'll take a look at that. Okay, so now that we have this up over here, you'll notice a couple of things. So obviously the project type is the PCB project, and you'll notice that the name is there, and then there's location and project kind. So let's talk about the name. As Travis is typing in a new name, it is putting in, you'll notice the repository folder is also following the exact same name as well. But I think more importantly, before we go there, let's go to project kind at the very bottom. So by default, you more than likely have something that says regular, and that just means it's a normal project. But if you do a drop down on this over here, you'll notice that there are two different things. There's VCS and there's managed. So VCS is if you're simply trying to use Subversion, and managed is if you have either Pcb Services or you have PCB Services, or you basically have a Vault or the Nexus system up here. So we do need to use the Manage. And when you do that, it's going to bring up a repository, okay? And that's why you see the repository folder down there as well. So the repository itself, we can't do anything about that. That's the one we're logging into. The only thing with the repository there is the name. When you initially set up the repository, you can give it a name, and that's the name we just happened to give it when we did that. But there's no other things in there except for that one particular, that's where it's going to go to. And as a matter of fact, if you had Nexus Vault, you wouldn't even install SOLIDWORKS Pcb Services on this, because you only really need to have one service on it. So just keep that in mind. So if you have Nexus Vault, that works just as well, and you'd see the same thing here. You can see the name. So you did type in the name. You also see the repository folder followed along with that repository name. It's just it won't put any spaces in there. However, you can change that repository folder to be whatever you want it to be. That's just really so that that project doesn't get intermingled with other projects. So you've got that capability there too. And lastly, I know these seems like they're a little bit out of order over here. On the left side, you'll see something called location. And in the location over here, this is where you're going to work locally. Because, of course, with any type of thing like the Vault or Nexus or PCB Services, whatever you call it, even Subversion, you can't work in the repository itself. You've got to always work local. So it wants to know where you're going to do this locally. So that is what would happen if we were going to do this project from the very start. We'd want to make sure it was managed. We'd want to make sure it had its location in the repository and that the repository was set up. So that's all we wanted to show over here. We're actually going to work on an existing project. For many of you, you probably already have an existing project. So you have something that's already in place, something like this, the rangefinder, which you've seen probably in other webinars here. We hit the 3 key there, so you see that there's already some 3D that's going on there. So we already have a project that's going. So how do I take a project that's in existence and now make it a quote-unquote managed project? Well, it's actually pretty easy to do. So we're going to right-click on the PRJ PCB, and about 5 commands below on that menu command there, you'll see Convert to Managed Project. So we're going to click on that here. And you'll notice that this prompt comes. So it's going to ask us for a project name. So the default one it's going to give is the same name as the PRJ PCB. You can give it a different name, okay? But you can also just take the default. There's also a description there. So Altium's already put in that particular description. If you want to have a different description, you can. The only thing I'd recommend is that if you have a lot of people doing this, so the services can work for multiple people doing Altium Designer or multiple people doing SOLIDWORKS CAD, make sure that these project names and descriptions are good, because if someone wants to open something in SOLIDWORKS CAD, there's going to be a big old list of these. And so make sure the name makes sense and the description makes sense so they can easily find it. So we're going to press OK and just leave this as is for now. And this is going to take a moment because it's now taking this project and it's getting it ready and to put it into services. What it's going to prompt us for here in just a moment is basically we need to push it into our repository. So keep in mind that the services, one of the key things it needs to do is maintain a head revision between Altium Designer and SOLIDWORKS CAD. So even though it's also helping with translation purposes, it also needs to know which one is the latest and greatest, because we can push and pull between the two tools. So you can see we're going to add these to version control, and so we're going to press commit at this time. And when it's done, we should see a couple of check marks to see that all of this is now the head revision. Okay, so now that we've got the head revision all set here, we are now going to push this over. So we're going to be pushing over this board. We've got a few features that are built into the board over here. Maybe we'll talk about that for just a moment. So, of course, we've got some of it half routed just to show that it can show some of the traces. And we can also, we've also going to show you basically the polygon pour, a cut through, and we'll also show you how we can manipulate things over here on the SOLIDWORKS CAD side as well. So it looks like it is. So what's going on right now over here is we see that the SOLIDWORKS Pcb Connector is up. So this panel will only show if basically the connector is there. So we're going to just click on this for one moment because it should have recognized this as being a managed project. So let's go back over to the top panel over there. So when it has declared itself to be a managed project, at this point we can now either pull or push. That's what we were looking for over here. So there's nothing to pull in because this is a brand new project. But what we're going to do over here is we're going to now push this over into the services. So when you press push, it's going to ask you for a comment. Whatever you put in there, be careful because your mechanical engineer is going to see that and it's a permanent record. So if you're cursing them out, it'll always be there, and they'll always be reminded of it for this particular project. So be careful what you type in there. Go ahead and press post at this time, and now you can see that it's pushing to the local surfaces. Okay. And if everything goes well, in a moment we'll see the timestamp in the SOLIDWORKS Pcb Connector panel over here, and we do now see it. So let's go over to SOLIDWORKS CAD. Okay, so now we're in SOLIDWORKS CAD, SOLIDWORKS CAD 2019. So one of the things we'll talk about here for just a moment is there is a panel that you'll want to turn on if you have this configuration set up. It's under the Tools menu, and if you go into Add-ins at the very bottom, you'll see something that's called SOLIDWORKS Pcb 2019, and that is what you'll want to turn on. So you want to have this available because this panel is going to look exactly the same as the one that is in Altium Designer. So go ahead and we'll close that here, and then we'll open up that panel. So you can see that that panel is there. So we're going to pull the board from Pcb Services at this time. And here it comes in. So we'll pull in the one that we'll pull in our project here. And so it's going to apply the changes. So one of the first things it's going to ask us to do is to save this because, again, this came from Altium Designer, but we're not working in Altium in terms of SOLIDWORKS CAD here. We're working in the native format of SOLIDWORKS. So the first thing it's going to ask us, well, when we're done with this file pull over here, we want to put it into our native file format here. So it's going to be applying the changes, and it'll be pulling these things in. It'll take a moment because this was a brand new run of it. So there's nothing in the cache at this point in time for it to quickly grab. So it's going to build everything here. But it doesn't take that long to do. And we'll just let it go through the motions. Okay, so you can see in the top corner, the board is slowly but steadily coming in here. And so it also has to create the components as well. And there it is. So so there's the board. It pulled in a bunch of things, and that's what we want to show you over here is the things that it did pull in. But actually, if you look on the left side where the cursor is, for those who do the mechanical work, you'll notice that these didn't come in as a bunch of little pieces. They all came in as their representative assemblies at this time. So that you don't have to do a whole lot of additional work here. In fact, there's very little work you have to do here in terms of the components. So for example, that battery holder that's in the middle over there, that's it's really a complete assembly, right? So you don't have to try to pull in all these little different parts that made that file up. Okay, so we've got that there. So a couple of things we'll kind of make mention of that you can see here. So what can you do here on the mechanical side? So one of the things is you can definitely change the board shape. You can definitely add holes. You can move holes. You can delete holes. And you can move components as long as they haven't been locked. So here's an example of moving C2. Okay, so we have moved C2, and if you'll also pull on U1 over here, you'll notice that U1 was locked. So in Altium Designer, one of the properties that we have for the footprints is you can lock them down. So if you lock them down in Altium Designer, they will also be locked in the SOLIDWORKS CAD as well. We didn't lock down C2, that's why we're able to move it. Now also notice that there is copper, and there's two ways to do copper in this whole flow here. What we're looking at is what's called a decal, and the decal was created to be like a sticker so that you can see the copper. One of the biggest problems that they had in prior versions of this is that you couldn't see the copper, and as a result, the mechanical engineers were moving things around, not understanding that, well, yeah, you see the package, but you're not seeing the copper clearances that were necessary as well. Now with this, you can see what's called a decal, and very fortunately, the copper, those decals come in very quickly. Now, if you have the actual copper itself, then what you go into is this little little gear at the top here, and it'll give you the option to do what's called model copper collaboration. So if you have to do like thermal simulation, or you really, really want to have that copper, you can turn that on. It takes a little bit longer, but you'll get the actual copper. In this case, it's just really acting more like a sticker for visual purposes, and that works fine for what we need to do. So we're going to play around over here and move a few things for you so you can see it. So here's an example here where we'll actually move and or create holes as well. So that's what you're going to see in this particular example here. So you can see that we did move the hole. And by the way, where that cursor is located over there near the top, where we just changed the hole, you can see that there's also a copper pour as well. So there is the copper pour that will come in. So if you do have the copper pours, it recognizes that as well. We'll do one more modification over here just to show this. So we've also added some holes in here as well. Now we did move some of the components. Well, U1 we couldn't move because it was locked. U2 we were able to move. We can also flip components to the backside too. Now for the mechanical folks who are watching this out there, make sure you talk with your electrical engineer when you do this. If this is a one-sided board and you flip something to the backside there, you may have added a lot of cost to the assembly. So make sure that they are copacetic with the idea of moving something to the backside of the board before you actually do that. But if they're cool with it, you can definitely flip a component to the backside, and that's what you can see over here. So that's what we've got over here. So pretty much all the primitives that you would use in Altium Designer are able to be seen here. They are represented here, and you can modify them to some extent, either by moving them, and in some cases, like with the board, you can actually change them. So that's what we've got. What Travis is also doing right now is he's going to put a big old hole in the board here, just to kind of show another feature of the tool once we push it back into Altium Designer. So he's added this hole in here. Now, of all these changes that have been made, what can we do with this? Well, we're going to push this back, and it's pretty simple to do. We just click on the push button. We give some commentary over here, and this is going to push it back into the Pcb Services. And so we'll post this here. And there's quite a few things that are going to get pushed over here, so this may take a moment, but we did get it there. And now we've got our date stamp. And so now we're going to go back into Altium Designer and see what happens. So we're back in Altium Designer over here. The first thing to take a look at is where the cursor is. We will get a notification that there's been a change. So Altium is pinging the Pcb Services every so often to see if there's been an update or a change to the document. And as a matter of fact, there is. So we're going to click on View Changes, and we're going to get a big shopping list of the different changes that have been made. So, okay, we can see here P1 gets flipped because it's put on the back side of the board. C2 got moved, and hopefully you can see this on your screen that things that got moved will actually trace across. And this happens both in the 2D and in the 3D as well. So if it's something new, it will flash it. If it was something that moved, it will show you a slow progression of where it got moved over to. So now, do you have to accept everything? The answer is no. So for example, if we didn't want that big old cutout that we added in there on the mechanical one, we don't have to hit the checkbox over there for that. And maybe we didn't want C2 to be moved as well. So what we're going to do is check the ones that we do want to move, and then we want to hit apply and not check the ones that we didn't want to move there. But now we've hit that, and now we've taken in those new changes. So you can see the new holes in there, but we've also have moved C2, or basically never moved C2, but we rejected the change to move to C2, and we don't have the cutout there anymore. Now we're out of sync with both Altium and SOLIDWORKS CAD. So now we've got to push this back to let the mechanical side know that there were some things that got rejected. So we're going to do this here. And so I'll post it. So you can see that's what we do. You just make the changes over on one side, you push them over, the other side obtains them, and you agree or disagree as to whether you want to accept or reject those changes. I mean, obviously at the end, something's going to have to be reconciled. So, you know, it makes sure that everybody's on the same page at some point. Notice over here in the panel, again, we got the new changes have been detected, so we didn't have to go hit a button to say refresh. You can see that there's been some changes here. So the C2 is going to get pushed back. The cutout is going to be removed. Notice the decal also got changed here too. So again, every time we make a change and we're not using the real copper, the decal has to change so that it looks like the copper and the silk is in the right place. So that's why you see the top overlay, the top solder, and the bottom solder there too. So you can right click and do an accept all. So we'll take all those and we'll hit accept, and basically now all those features will be pushed in, and we'll be back in sync between Altium Designer and SOLIDWORKS CAD. And that is really what we wanted to demonstrate over here. That may be something that you have an idea for. So what I would like to do at this time is, if you have your questions panel, feel free to write a question in there. What I'm going to do while you're writing those questions in there is I am going to go, okay, so I'm going to go here to the current slide here, talk just a moment about 9.connects. Look, we know you're here for a reason, and hopefully we were able to show you the flow between MCAD and ECAD. It's getting better all the time. Yeah, a few little flaws here and there, but to be honest with you, they've really been trying to make it so that these two tools can talk to each other, even though they're two completely different domains. And hopefully you can see it here in action. So we're able to do a lot of changes. I mean, we really did force a lot of changes here all at once, but you can see, hopefully saw that in action. So who are we here at 9.connects? We provide a number of different things. We do training for those who want to learn the tool. For Altium Designer, we have something called a boot camp. So if you want to get a good feel of how Altium Designer works from a process point of view, there you go. If you want to get into some of the more specific things of Altium Designer, then we have our Spec Ops training. We also have what we jokingly call our stealth trainings. These are trainings where we can provide information. We don't normally get enough people to really warrant the creation of a manual. It does take a lot of effort. But we do have knowledge, things like in library methodology, Nexus Vault, SPICE simulation. So there's certain things out there that people want some assistance with. And if you go to our stealth training page, you can see that entire list of the things that we do provide. And there's also what we call the one-day trainings. These are formal one-day trainings where if you just need a refresher on a particular thing like schematic capture and libraries, we've got those as well. There's pages for each one of these if you want to look on our website. Also for services, for those who need a hand, we do design both circuit and mechanical. So we do have a few people on our staff who are really well trained in SOLIDWORKS CAD, but we definitely can do PCB layout, and not only just in Altium Designer, but several other tools as well. So if you are using Allegro or using Expedition, let us know. There are people that are affiliated with us that can assist with that. There's library component development. We have a lot of people who come to us now asking for a good library scrub, and we're getting that down to a science. So if you need some help with that, we can certainly assist you with it. And of course, circuit simulation as well. And a lot of people have been asking us more and more about the Sigrity and the other type of simulation. And we are getting into that because we're just finding that the days of just putting blind faith into the work are coming to a close as things getting more complicated, and there are things that radiate, things that signal integrity things are getting a little more trickier. So we are definitely looking and been spending more time in the circuit simulation domain. In terms of consulting, we do design and process assistance. We can do RF, high speed, power, analog. Look, if there's something that you need help designing, let us know. We can certainly assist you with that. And even in design methodology, library methodology, pardon me, a lot of people are also asking, it's like, well, how do we set up our libraries to be efficient? And we've been around that block many times here. But with that, we're going to wrap this up. I want to thank everybody for their time, and have a really wonderful year. I hope 2019 treats you all great, and we'll see you in January. You take care and have a great day.